Okay, so we're going to look at the 12-3 assignment together. Number 1, find the surface area of the spheres. Leave your answer in terms of pi. So number 1, we're dealing with a whole sphere here, not a hemisphere. So the surface area formula is 4 pi r squared. And then I'm going to write 4 pi, the radius is given, it's 9, so it's going to be 9 quantity squared. So 4 pi 81, 81 times 4 is 324. So you get 324 pi square meters. Number 2, this 14 is actually pointing at this whole diameter. I'm sorry if it looks like it's the radius or it's just pointing at the radius, but really it's this whole chord here, this diameter. So since it's a hemisphere, the volume of a hemisphere, sorry, just kidding, that the surface area of a hemisphere is 3 pi r squared. So 3 pi, the radius is 7, so 3 pi 7 squared, 3 pi 49, so 49 times 3 is 147. So 147 pi square inches. Okay, so now I'm going to look at number 3. So you're going to find the surface area of the sphere if the great circle area is 36 pi square yards. Okay, so the surface area of the sphere formula is 4 pi r squared. And the great circle area is 36 pi square yards, or just, you know, when you're dealing with the great circle area, it's the area of the circle essentially, which is just pi r squared. So we know that 36 pi square yards is equal to pi r squared, right? So here is pi r squared, and then what I'm going to do is I'm going to replace pi r squared with 36 pi square yards. So 4 times 36 pi, right? And 36 times 4 is 144. 144 pi square yards. And that's number 3. And now I'm going to look at number 6. The great circle has a circumference which is equal to 2 pi centimeters. Okay, so I gotta find the surface area of the sphere. It's 4 pi r squared. The radius is not given. The radius is not given. So let's go ahead and use that circumference formula. So circumference is equal to 2 pi r, and c is 2 pi. So 2 pi, which is equal to 2 pi r. And I'm going to solve for the desired variable, the radius. So I have r equals 1. So if r is equal to 1, I have 4 pi times 1 quantity squared. And we know that 1 squared is just 1. So you're really left with just 4 pi. So 4 pi square centimeters. Okay? All right. Now we're going to be dealing with volume here. So let me just tell you what to do with 10. The surface area formula. Oh, just kidding. We're dealing with volume, sorry. The volume is equal to 4/3 pi r cubed. And we know that this is the diameter. So the radius is going to equal to 1. So what do I do? Well, if the radius is 1, you get v equals 4/3 pi 1 to the third power. And 1 to the third power is 1 times 1 times 1, which is just 1. So this just goes away. So you can say that your answer is v equals 4/3 pi cubic centimeters, and that'll be your answer. And when you're doing number 9, you're going to treat this as a regular sphere, so use the volume formula. So 4/3 pi r cubed, plug everything in. Well, you're just plugging 5 in, right? And whatever the answer is, you're going to divide that by 2 so that you get the hemisphere, the volume of the hemisphere. Okay, so that's how you should do number 9. Okay, and then this, you're just not given a picture, you're just given the information where the radius is 1.4, okay? And that applies to 12. And then 13, ooh, 13, what is this one? You want to find the volume of the sphere where the area of the great circle is 49 pi square meters. So the area of the great circle is 49 pi square meters. And let me see, is there a play that I can do? No, I don't want to do that. I'm just gonna play it safe here. So a equals pi r squared, and I'm gonna replace a with 49 pi. Okay, so I know that both sides of the equation, they have a pi, so I'm gonna divide both sides by I'm gonna divide both sides by pi here. So I'm left with r squared is equal to 49. So taking the square root, r is equal to 7. Now if r is equal to 7, then you should be able to find the volume of the sphere here. Number 14, find the volume of the composite solid. Okay, so if I'm trying to find the volume of the composite solid, what figures do I see here? I see a sphere and I see a cylinder. So you need to find the volume of the this is the hemisphere and this is the cylinder. So you need to find the volume of the hemisphere. And you need to find the volume of the cylinder. So the volume of the hemisphere is, well, we gotta do 4/3 pi r cubed, and whatever that is, you're going to divide that by 2 here. And then the volume of the cylinder is equal to the area of the base multiplied by the height of the prism. So once you figure out the volume of the hemisphere along with the volume of the cylinder, you should add those two volumes together so that you can have the correct answer, the volume of the composite solid here. Okay? So be sure to try that on your own. Number 15, find the volume of the shaded solid. Okay, so what do we have here? We have this hemisphere here, and then we have a, let's see, what type of prism is this? This is going to be a rectangular prism, it looks like. So I'm going to, it's basically the same idea, like this one right here, but this one is asking you to find the shaded solid. So when you're trying to find the shaded solid, you're going to do the shaded solid minus the unshaded solid, just like what we did in unit 11. So let's find the volume of the hemisphere here. So the volume of the hemisphere is 1/2 of 4/3 pi r cubed. Or you can say 4/3 pi r cubed all over 2, how I wrote it over here. But basically they're the same thing. So, okay, so let's do 1/2 of 4/3 pi, and then what's the radius? So if this thing is 10, that means that the diameter of this hemisphere is also 10. So the radius is 5, right? The radius is 5. Okay, so we have 5 cubed. Now I'm going to use my calculator, and I'm going to calculate this. So 4 divided by 3. And I'm going to include the pi this time, because it's going to be really hard to leave our answer in terms of pi here. So 4/3 times pi times 5 to the 3rd power. And okay, so I got 523.6. That's the volume of the hemisphere. Now I want to go ahead and find the volume of the prism. It's a rectangular prism. Okay. So it's going to be the area of the base multiplied by the height of the prism. The area of the base is going to be a rectangle here. I'm gonna have to think about this one real quickly. This is kind of weird because I'm trying to figure out what type of prism this thing here is, but it seems like what I need to do is, hold up, let me try something. I need to think about this real quickly. Oh, wait, hold up. You know what I forgot to do? I forgot to divide this by 2, right? I gotta divide that by 2. So if you divide that by 2, when you divide this by 2, you get 261.8, okay? And then hopefully I'm on the right track while I'm trying to figure out this problem here. All right, perfect. Okay, so this is kind of weird, but the area of the base, this is my base, yes. Because that the radius is 5, right? So here's my circle. If the radius is 5, right, that means that this side here is 10. And we know that because it says right here. But if we look at this perspective, from the center to the side here, right, a straight segment here, a straight line here, that's also 5. And then this is also 5. So really the diameter here is 10. So we can assume that this side here is 10 as well. So you're dealing with a square. So the area of the base is 10 squared, s squared, right? That's going to be 100 multiplied by the height of the prism, which is 13. Okay, so that's going to give you 1,300. Okay, and remember what I said at the beginning. It's 1,300 minus 261.8. You're doing the shaded minus unshaded. So you get about 1038.2, and I know the key says 0.3, but I'm pretty close enough, and I'm happy with this answer. So centimeters cubed, that's my answer. Okay? Sorry that took me a long time. I was trying to figure out the game plan for that one. Okay. And then let's take a look at number 17. So, what is the circumference of a sphere that has a volume of 92, or that number 9,202.77? Actually, I want to go over number 16 first, because then we're going to go to 17. I'm not gonna go through the whole problem here, but I'm going to give you a hint. It says, which has a greater volume? Show your work to justify your answer. You are trying to compare this to this. Which one has the greater volume? This one has, you're dealing with a sphere with a radius of 2.3 yards. And then this one, you're trying to figure out the volume of the cylinder with a radius of 4 feet and a height of 8 feet. Now, here's the thing, y'all. These two objects are dealing with different units. So you have to match them in order for you to do the problem. If you do remember, 1 yard is equal to 3 feet. Okay? That's my hint to you. 1 yard is equal to 3 feet. So what do you do from there? Now, let's go back to number 17. What is the circumference of a sphere that has a volume of this? Well, the volume formula is 4/3 pi r cubed. And V is actually that number, so 9,202.77, which is equal to 4/3 pi r cubed. Okay? I'm going to multiply both sides by 3/4. So the 4s will cancel and the 3s will cancel. I'm going to multiply this number by 3/4. And you get 6,902.1, let's say that, which is equal to pi r cubed. Now I'm going to divide both sides by pi because I need to get r cubed by itself. So I have this all over pi, which is equal to r cubed. And now I'm going to take the cube root on both sides. So to do that, you're going to press math on your calculator, scroll down to 4, and then input 6,902.1 divide by pi. And, okay, well, the radius is going to be 13. The radius is 13. So if the radius is 13, what is the circumference? Well, the circumference is 2 pi r. So I'm replacing r with 13. And you get 26 pi meters. And that's 17. All right. So I am done.